Right. Um, s- so without further ado, I am ready to start. So my name is Leslie Thatcher. I'm the Director of Program Development and Strategy at the Transition Center at Perkins School for the Blind. I am delighted you're all here joining us for our third of three webinars on tactile graphicacy. And tonight's topic is teaching students to create math-related tactile graphics. Just a few housekeeping reminders. This session is being recorded and uploaded to our website landing page towards the end of this week. We have a little tidying up we need to do before we can post it. Amanda, with whom you may have gotten a few emails, has sent emails with a link to that site and is also putting it in the chat just this moment. We encourage you to bookmark this and watch this again. Share it with your colleagues and refer back to this. Hopefully, it's the beginning of an increasing set of resources for you all. We'll be sharing a document of the chat and the transcript from tonight as well on that page. Once the session is finished today, please stay on for just a few moments for some exciting announcements as well. So we're delighted you're here. And without further ado, I'm going to hand our floor over to our presenters tonight, Susan Osterhaus and Sarah Larkin. Take it away, ladies.
Well, I'm Susan Osterhaus, and I am the statewide mathematics consultant at the Texas School for the Blind and Visually Impaired in Austin, Texas.
And I am Sarah Larkin. I'm the state math consultant in Iowa, specifically for students who are blind or visually impaired. So today, what we're going to go through for our objectives is by the end of this session, you will be able to state why it is important for a student to be able to create their own drawings. You'll also be able to identify at least 3 ways that a Braille user can draw using the Braille writer in math class. Also identify at least 3 tools and materials that can be used for students to make tactile pictures, especially in geometry. And lastly, to identify at least 3 other strategies for helping students create their own drawings in mathematics. So this goes right along with the standards for mathematical practice. Those of you that are Common Core states are familiar with that terminology, but even if you aren't a Common Core state, often you have similar sorts of structures to your standards. In the standards for mathematical practice, it is important to model with math. And when we think about modeling, that really includes a lot of different things. We want students to draw and express their reasoning through those drawings. And that includes tools such as diagrams, your two-way tables, graphs, flowcharts, and even formulas that are represented graphically. We also want them to create a picture that describes a particular situation that describes a problem. We also want them to use appropriate tools strategically. So what tools do we want them to use? Of course, those tools that will help them model that math. We want to have them consider what's available for possible tools that they can use when they're solving a problem. We want to make sure that they can use that Braille writer and paper and quickly create and model those problems. We also want them to become familiar with all of those tools that are appropriate for their particular grade level or the course that they're taking so that they can make decisions about what might work best in any particular situation. So first of all, let's talk. What we would like you to do today is to go ahead and flood the chat. Remember, Leslie said that we're going to also include the chat on the website. As we go through these slides, we would like you today to please use that chat to share other ideas. This is only an hour. There's so much more we could put into this. So we want all of your great ideas expressed through the chat as well. Be sure you're focusing on the students creating and drawing to express their thinking. Include what particular concept you're talking about. For instance, you might say fractions, and that to show that they might draw a shape using stencils on the draftsman board and do some shading of what fraction is shaded on that board. So that's just an example. Feel free to share lots of your ideas. So the importance of drawing is sometimes with our students, just like with any student, it says often in worksheets to draw to express your thinking. We don't want to say, oh, don't worry about that, because that will cause gaps in their understanding. Producing those drawings actually allows the students to really show what they're thinking. It's part of that learning process. We've talked a lot in the last 2 webinars about reading tactile graphics, but in the process of creating those tactile graphics, that will also become more, they'll also become more proficient in reading the tactile graphics. So we want them to make sure they're doing both. We want them constructing the graphs, drawing the geometry shapes, drawing the processes or stages of their thinking, and producing and modifying those drawings or diagrams that they're coming up with. This also allows the teachers to see if there's some misunderstanding in the concept that they're trying to understand. So addressing those misconceptions early is really important.
And now we're going to talk about, actually, we're going to do a little bit of reviewing about beginning tactile production skills. In fact, those of you who attended our webinar 1 may remember this particular slide. And we just want to reinforce the fact that it needs to be started early, and a lot of these skills will be still continued into all the way into high school. So for example, the first one, color inside raised lines or mazes at a young age, because at when they get to a secondary, when they get to high school, they are going to be needing to actually shade particular areas of a graph and so forth, and they need to have had that experience when they're young. They also need to be able to trace inside stencils on a draftsman board, a tactile doodle, or an in-text sketchpad, and they will be continuing to do that all the way up through the grades and even into high school. They still will need to be able to peel and stick textures and shapes onto paper to form pictures, or use magnetic shapes or those from the Wheatley board or to make pictures or on a magnetic sheet or the Velcro board. And then finally, they will need to be able to create pictures on the Braille writer. And then we can also have a graph using grid paper along with tactile dots. So just keep that in mind. We talked about that in webinar 1, but it is still very important. Next slide, please. Okay, so now we're going to talk about how we can do some of these things. When we discuss patterns, that's what I think about is algebra. And algebra starts very early on and continues obviously all the way into high school. And we actually have subjects that are called Algebra 1 and Algebra 2. But how do you start with them? Well, with the Wheatley board, which is a picture here of using the Wheatley board, it's on a Velcro storyboard, some people call it. And we have square, triangle, square, triangle, or maybe that's a rectangle. But anyway, we have that pattern. That can be created on a Wheatley board. It can be created on a Braille writer. And here we have AAB, AAB, AAB. So again, that pattern, this is the beginning of algebra. And we also have a picture of a young student who's using the hundreds board with manipulative set. And again, there is that pattern. This time it is star, circle, triangle, square, star, circle, triangle, square, star, circle, and they're just about to put that triangle in the next slot there. Okay, and then we can also do that with stickers. So we're going to show you lots of different ways that you can do this. So if you don't have one particular manipulative, we have plenty more to talk to you about. And you can go ahead and feed the chat and say, this is what I use if you'd like to do that now. Okay, let's look at the next slide. Another thing that you can do is you can represent addition or subtraction using all kinds of wonderful things. And we're going to show you a few examples. For example, that first picture, we've got tally marks, and that happens to be on the tactile doodle from APH. So we've got some tally marks over there, but you could do it on the Braille writer. You could have, in this case, CCC, if you're thinking in terms of of those actually meaning letters, then there's a space C, 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 C. So you've got three. You might be saying, oh, I'm going to add 3 and 4. That makes 7. Or you could do something like this without a space. You could have C, 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 sorry, 6 C's and 3 full cells. You can say, oh, I have 6 of those and 3 of those. What do I have all together? You can have objects in a sorting tray. APH has some wonderful ones. You can use any kind of stickers. You can use the hundreds board with manipulative set that I just showed you in the last slide. In this case, we also have snap cubes. You could use Unifix cubes. You can use Omnifix cubes. Anything that you have around that will be like that. Also, I want you to notice that what these are laying on top of is just that now I'm gonna say it wrong. The basically what you have in the kitchen, shelf liner, something like that is the least expensive. That's what we use. We just go to the dollar store and get some shelf liner, and that keeps things in place. Okay, next slide. Oops.
Hang on. Yep.
Yep. Okay. So now we're going to talk about 5 and 10 frames. Uh, Actually, I'm going to tell you something. We have the Nemeth Braille Code curriculum, which is also found on the Perkins Paths to Literacy website. We came up with our own 5 and 10 frames. So if you want those, you can go there and get them as well. But in the meantime, while we were doing that, APH came out with their 5 and 10 frames, which are wonderful. And they also came out with the tokens that go with them. And the tokens also match up beautifully with our embossed 5 and 10 frames that we use in the curriculum. You can use a 2x5 array on the Braille writer. You can have an APH scorecard cut in half or fourths. Way over there to the right, you can see those APH scorecards. As I said, they could be the 5 and 10 frame if that's what you need. And we have again a Braille template on the Braille writer or with stickers. We have a little boy with his own whatever his teacher made for him, very similar. And I think those are the little cute little teddy bears that he's got that he's using. Okay, what's next? We're now going to talk about base 10 blocks or digiblocks. Now, base 10 blocks have been around forever, and that you can actually get them from APH inside of their big suitcase focus in mathematics. And so you could borrow them from your math teacher. Digiblocks actually cost real money, but a lot of elementary teachers really love the digiblocks. And a lot of the teachers at TSBVI use them. And you'll see that this little gal, she's just getting ready. She's got her sorting tray. She's got her digiblocks, and she's about to put them in the ones, tens, and hundreds place. That she's just at the beginning there. That's what's going on the left. And on the right, we have those base 10 blocks. And what we're doing here is we're going to have probably an addition problem. And so we've got, if you look below in the Braille, for those of you who can see that Braille, what we've got is 346. And in Braille, we've got 3 full cells. Then we have dots 1, 2, 3 being used for our tens, and then a single dot 3 being used for ones on the Braille writer. But we have that also duplicated on these in this sorting tray where we have the base 10 blocks. So we have 3 base 10 blocks, 4 of the the tens,
Along.
and then 7, I think what is it? 6 of the units, and the same thing below 507. So again, all of that, you can use any of this combination or anything that you want to throw in the chat. Okay, keep going. Now, money. Now, if you're asking people to identify money, you are going to want to use the real money. You do not want to use anything but the real money, nothing plasticized, etc. But if you are actually having a tactile graphic where the students have to figure out how much money do they have, and this might be on an assessment that you either make up or that is a standardized assessment or in a textbook, they are going to use Braille abbreviations. And so for your dollar, you're going to want to have, like in this case, we've got it in Braille, .4S1, .4S5 for $5. And also the picture is showing you how you would fold real money and learn how to fold that for ones and fives and tens and 20s and so forth. But if you have a tactile graphic, and they in this particular case, they're supposed to figure out how much is a quarter, a dime, a nickel, another nickel, and a penny. You can use these short braille abbreviations, PN for penny, NK for nickel, DM for dime, QR for quarter, HL for half dollar. These are straight out of the Tactile Graphics Guidelines for 2022, so they're totally legit. Okay. It's up to you now, Sarah.
All right, so let's talk a little bit about open number lines. This is another concept as students start adding or subtracting larger numbers. They start using open number lines. Now, visually, we have a number line, and it has basically arcs that go from one number to the next. So if I was adding, for instance, 247 plus 325, I could take the 247, which is on the left side of my number line, and then I have an arc that says plus 300, and it leads to the number 547 because 247 plus 300 gives me the 547. Then I have another arc, and above that arc it says plus 20, which puts me at 567. Then we have another arc that says we're adding 3 to bring us to 570, and a fourth arc that says plus 2 that brings us to 572. The problem is this can be very cumbersome for a student to have to do all of the drawing of the lines and the arcs and so forth. But on their Braille writer, there's a couple of ways they can accomplish the same task that this number line does. One way is to use columns on the Braille writer. So they can write that 247, and then just to the right of it, write plus 300. Go to the next line and write the answer, which is 547, and to the right of that, write plus 20. On the next line, they write the answer of 567, and then to the right of that they're adding 3. And then they're going to go to the next line and write that answer of 570, to the right of that saying they're adding 2. And then on the final line, 572 for their answer. A second way they can do it is by actually rotating the Braille writer up and down. So they would start a couple lines down from the top of their page and write the number 247. Then they can rotate the Braille writer up and write plus 300. Then when they rotate it down, they can reference the 247 plus the 300 to write the answer of 547. Rotate it up for the plus 20, down for the answer of 567, up to say plus 3, down for the answer of 570, up to get plus 2, and down for the answer of 572. So just a couple of ways they can do open number lines and still have the same concept expressed. Arrays are used commonly for multiplication, and that's just an arrangement of rows and columns. Basically, the student can use any character they want. We have an example visually of full cells where we have 3 rows of 4 full cells in each row, and then we have 4 rows with 3 cells in each row. And both of those arrays express 12. And it's just a quick way, because they've already got the Braille writer out, to write their problems, to write their answers, so they can quickly express that. We could also use manipulatives, such as the APH hundreds board and manipulatives kit. So we have that same arrangement where we've just used the red circles that go with that manipulatives kit in that same arrangement of rows and columns. They can also use graph paper with tactile stickers or dots on them. Even tally marks on a drawing board will work. Or we have an example with Omnifix cubes that are connected with 3 rows and 4 columns. So that there's lots of ways to express that same arrangement to make that drawing. Now, as the students get a little older, they start talking about the distributive property. And they use area models, are specifically noted in the Common Core, to represent the distributive property. So if I have 3 times, open parenthesis, 4 plus 2, close parenthesis, I would normally learn how that distributive property works, but I would want to draw what that represents. So a couple of ways I can do that. With that hundreds board and manipulatives kit, I can use circles to represent the 3 rows and 4 columns, and then the squares to represent the 3 rows and 2 columns. So I really have 3 rows of 4 circles plus 2 squares. And so I've represented that, and that total then is the same as if I were to multiply 3 times 4 to get 12 and 3 times 2 to get 6 and combine those. On a Braille writer, again, I can just use 2 different symbols. So there I have 3 rows of 4 full cells plus 2 X's. And I have that same sort of arrangement real quickly just using those Braille symbols. So visual fraction models are another thing that is really common throughout the Common Core. And luckily we have the Math Builders Unit 7 set that has fractions, mixed numbers, and decimals for it. So in the first couple of pictures, the first one I have a set, the circle tray, and it has a semicircle or half in the first circle. And in the second circle, it has 2 quarters to show that it takes up the same amount of space as 1/2. In the next drawing, I have the fraction tiles, which are labeled with those fractions in the kit. And I have, in that case, 2 of the 1/3 fraction tiles. And above that, I have 3 of the 1/5 fraction tiles. And then I can see that the thirds, the 2/3, it takes up more space or extends further than the 3/5. So 2/3 would be greater than 3/5. We're just expressing that through the use of those manipulatives. Another thing we can do is even use just graph benders and different sorts of shapes to represent a fraction. So I might have some squares and some triangles, and the squares might represent the shaded part. Draftsmen and stencils, they could certainly make a shape using stencils on the draftsman board and draw their lines and then shade in those certain sections. In the next picture, I actually have a circle cut from 2 different pieces of textured paper. One is a rough and one is a little smoother. I've cut a radius in them, and then I actually interlock the 2 circles. And now I can simply rotate those circles to express a bigger fraction or a smaller fraction. I can use graph paper with stickers to represent shaded areas. Even egg cartons and muffin tins are great with objects in the particular sections. We can't forget about the Braille writer again. I can use my full cells to represent the shaded part and the letter X to represent the unshaded part. So if I have 3 full cells and 2 X's, that's 3 of the 5 cells or 3/5 that is shaded. And of course, we can come back to using those scorecards. I can cut those into sections. So the first one I have is just a 2x6 array from that scorecard with half of the little bubble sections pressed down. So that represents a half. I have another one that's just a 2x5 array with 6 of the 10 that are actually pressed down. Tape diagrams. So tape diagrams are one more concept that's often listed in the Common Core. These are very visual and they include usually squares that or rectangles that are connected, but they're used to represent those fractions and ratios as well. So again, we can use that full Braille cell a lot of times to represent those equal sections or equal parts. I can use graph paper with tactile stickers or the draftsman with stencils, or we can go right back to the Braille writer. I have a picture of, let's see, we have 3, 4, 5, 8 rectangles that are connected. 3 of them are shaded. The 3 that are shaded has a little brace that says it equals 12. And then the full 8 represent 32. So the student can just put 3 full cells equals 12 and 8 full cells equals that 32. And then, well, if 3 cells equals 12, what does 1 cell represent? And so they can do that mathematics along with it. The second example of a tape diagram talks about a ratio of boys to girls is 3 to 5. and they have to draw a tape diagram. So the other students might take out their paper and pencil, write boys, and put 3 connected rectangles. What our students can do with Braille writer is just write the word boys and use 3 full cells to represent the boys, and then write girls and 5 full cells to represent the girls, to express that same ratio that's drawn in the picture. So one piece that's really simple to take out and doesn't take a lot is just using regular paper. Just take out a sheet of Braille paper and you can represent a lot of things just through paper folding. That includes dividing a paper into halves or fourths, even taking a rectangle and putting a fold and making it into 2 triangles. And you can use it to put diagonals of quadrilaterals. You can have it in the shape of a triangle, and then they fold it where the height would belong. I can even do 2 folds that are going the same direction to get parallel lines, or 2 where one might be horizontal and the other vertical to make perpendicular lines. Even any random 2 lines to talk about the intersection of those 2 lines. Where do they cross? Or I could take just a paper that has been cut into a circle, and I can fold it at a chord, at a radius, or even at a diameter. Next, angles. There's acute, right, and obtuse angles. So I can make my folds, those lines become further apart or closer together to form those acute, right, or obtuse angles. When I make those intersecting lines, that causes a linear pair and vertical angles. So all of that terminology can be handled just through paper folding. All right, reflections. Real quickly here, I just have a couple of wiki sticks on a piece of paper. And with the general concept, I can just take some foam shapes and show it in the first quadrant and in the second quadrant, the same distance from that y-axis. I can use graphic art tape to make those shapes, or tactile stickers on that same sort of paper. More specifically, I can use actual grid paper. So then they can count the number of squares away from that line of reflection. So in the example, we actually have a teacher that has created a quadrilateral, an irregular quadrilateral, and then they've used push pins for the points. And then the student can count, okay, how far is this point from that line of reflection, and count the same number of squares on the other side to produce their new push pins and connect them with just a rubber band. Rotations, I can do this easily on the Draftsman board using those shape stencils. In this particular case, the student drew the axes, just a vertical and a horizontal line with a straight edge. And then they put the stencil on that particular axis, traced one of the triangles, but then used a wiki stick to mark where the origin was, so that then when they rotated the stencil, they could make sure that that wiki stick was still at the origin, and then trace that same triangle in the third quadrant instead of in the second, or the fourth quadrant instead of the second quadrant. Translations. For translations, you can start out very basic with just a cookie cutter on the tactile doodle, and even just shifting that left or right or diagonal. That's all a translation is a shift of that shape. So they can just trace inside of that cookie cutter. It is easier to trace inside compared to outside. It helps to contain where their drawing tool is. Once they get more advanced with the basic concept, then they can actually use grid paper or the graphic aid for mathematics to actually use stickers or push pins to create certain shapes that have just been shifted. And they can count those squares to make sure it's always shifted the same direction. Dilation. So dilation is like a it's going to change the size. It's going to make it bigger or smaller at the same rate. So in this particular example, we have a cork board with some tactile graph paper on it. We could use the graphic aid for mathematics the same way. And there's a triangle that's produced with 3 push pins and a rubber band. And then you can just make a new vertex for a new triangle. And I can put that base by multiplying, in this case, by a factor of 3. So the base of the smaller triangle was 2. So now I want to go 6 to the right to give us a dilation that's 3 times as much. From that same point, I was going just up 1. So for a factor of 3, I would go up 3 from that initial point. And then I can place that new rubber band on there and get that dilation that is 3 times as large. 2D shapes. Lots of things I can do with 2D shapes. We have a link to some math stencil videos for you, but we can use geometry stencils, the Draftsman board, Tactile Doodle, or the Intact Sketchpad to create things like triangles with an exterior angle. We could do different shapes. We can even mark congruent sides with wiki sticks or congruent angles with tactile dots that I've just punched out with a hole punch. So lots of ways that we can make our shapes, including, of course, that graphic aid for math with the push pins and the rubber band. Quick, easy ways to produce those 2D shapes. So what about 3D shapes? Well, the geometro shapes are a great way to create those 3-dimensional figures like prisms and pyramids. There's even some that are cones and cylinders that you can get from APH. Another thing you could do is use those same stencils and teach them how to draw those 3-dimensional shapes on a Draftsman or the Tactile Doodle or that Intact Sketchpad. So teaching them how to be able to create the same shapes that everybody else is. And Susan?
Yes, and now we're going to talk about parallel and perpendicular lines in two-dimensional types of things. And first of all, you're going to need some type of drawing board. And the picture here has just a rubber pad, but you could also use a clipboard with some craft foam on it. Or if you happen to have an old Sewell raised line drawing board, you could use something like that. And then you need your braille paper, sewing tracing wheel. That's what I first started with. One of the teachers in the homemaking department brought me that, and it was wonderful. I loved it. In this particular case, to make parallel lines, you can use a ruler. You can just draw on one side of the ruler, on the other, don't move it, and you've automatically got parallel lines. You can also use rectangle stencils, graphic art tape, wiki sticks. You can even use graph paper if you would like to make your parallel lines with that, or perpendicular. And also, don't forget about the Wheatley board or storyboard with those Velcro lines that come with it. And a lot of teachers I've seen, even in high school, using those. They're meant for orientation mobility, but we math people can steal those away from the O&M folks. Okay, let's keep going. We now want to talk about parallel, perpendicular, and skew lines in 3D. Okay, so if you're going to demonstrate this, you can use your arms. I don't know that I can show you exactly, but this is the type of thing that I would use my arms for and show students, or have them use their arms. You can use sticks, but what's best, of course, I just love the APH Geometros. And so if you have I think that I'm not sure that you can still get those orange sticks anymore. They might have been discontinued. I'm very sad. So if you have them, hold on to them. And excuse me. So we've got the APH Geometro Velcro shapes and hook material rods, if you can still get them. And in the first picture, we have parallel lines, and I have a video all about how to use those with parallel lines. Another one on perpendicular lines video, and then skew lines video using those. So please take advantage of those if you need a little lesson on that. Okay, next slide. Platonic solids. Okay, again, still using those geometros. We have nets and platonic solids videos, so you can check all that out. And if you don't know what I'm talking about, go to those videos and find out. And by the way, just a real quick lesson. Your platonic solids are a tetrahedron, That's 4 triangular faces. You might call that just a triangular uh, pyramid. Cube, which is 6 square faces. Octahedron, which is 8 triangular faces. Dodecahedron, which is 12 pentagonal faces. And an icosahedron, 20 triangular faces. The students love to make those. And if you want to get in good with a geometry teacher, you definitely go to the geometry teacher with these, and they will love you forever. Okay. Keep going. And so 3D figures and math plans. We have to do this a lot for assessments all the time. And people, when I've gone into certain classrooms, most math teachers are, unfortunately, at least the ones I've seen, are still using all these little wooden cubes to try to do this. And the wooden cubes are flying everywhere. Please use one of these. If your math teacher is still doing that, again, they will love you when you show them this. Okay, I'm going to show you 2 different kinds. On this particular one, we're talking about Omnifix cubes. Omnifix is different from Unifix. Omnifix means that you can connect these cubes to each other, all 6 sides. Okay, so what you start with is a map plan, which gives you the top view. And you'll see here, we've got 1, 3, 2, 4. You build your building. This is your kind of your blueprint to build the building. And hopefully you can see that we've got 1 cube, and then right next to that we have the I guess that's 3 tall, but you can't see the bottom one because it's next to the one that you started with. And then we have 2, and then finally 4 in the background. So again, the students can make these, everything sticks together. They can see the front side, the left side, the right side, pick them up, etc., and they're not falling all over the place. Now, going from 2D to 3D, the student uses the map plan. Okay, so here we've got a plan over here. They take, in the case of the 1, 3, 2, 4, they take that and build their 3D figure. But then they can also go from the 3D and build their map plan. What I have them do is I have them build their own map plan, build their own figure, and then pass their plan to another student who has to build their building. And they absolutely love it, I guarantee. Okay, how else can you do this? There's another, by the way, Omnivix cubes are relatively inexpensive, but they do cost real money. If you need APH federal quota money, go right to the stack ups here, which again, they have even more. Omnifix cubes doesn't come with everything I was showing you. You need the graph paper and so forth. The stack ups actually come with the map plans. As you can see, they're all beautifully laid out. And I just want my kids, like to have them making their own, but you have them all laid out beautifully here. And you can see these same orthographic views with the stack ups, the top view, the bottom view, side view. And the stack up includes the Velcro cubes, the map plan cards, 3D figure cards, and grids and Velcro squares for all of those orthographic views. So just know that this is something that is fantastic. Your math teacher, again, will be so excited that you have something that probably they're having trouble with their students. And I did want to say that this whole thing with the map plan and so forth, it is approved and it's in the guidelines and standards for tactile graphics 2022. And in fact, I'm the one who wrote the map plan for that. So we're in good shape. Okay, keep going. Constructions. Okay, we are doing constructions these days, guys, and I do show you a few constructions on a video if you want to see that. But want you to know that what do you need to use to do these constructions that our students can do. You need an APH tactile compass for math and art. That is the one that is still available on federal quota money and it's not discontinued. You also need a drawing board, as I mentioned before, which can be a rubber pad, stool raised line drawing board, or a clipboard with craft foam and braille paper. And if you still have one of these around, grab it and keep it. A Howe Press compass and drawing board, which are discontinued, but if you've got them, hold on to them. Fiskars rubber tipped has also been discontinued from Fiskars. And I will, and we've got pictures here of all the different types of compasses and so forth. Sarah and I bought up all the Fiskars that you see here pictured here that we could get our hands on, and then they were gone. And so, well, Sarah wasn't satisfied with that. So I'm going to let her show you what she did
Oh,
in
we
the
weren't.
next
You can't let anything just become discontinued, right? So
slide.
I went to Iowa State University and I said, hey, we need this. And they contacted Fiskars and they said, can we recreate this and put the drawings, the 3D drawings, out for anybody to use? And Fiskars agreed. So Megan McGew from Iowa State, well, she's from Wisconsin, but she attended Iowa State. She actually produced the different parts to this compass. And so you can then just create them with a 3D printer, get a screw and a nut and put it all together. Believe it or not, for my rubber tip, I've actually just used a glue stick, and you can shave a glue stick with a pencil sharpener and just put it in there, and it's just like a rubber tip that works great on the Draftsman board. So it doesn't slip so bad, and you can still draw your circles and have them raise up towards you as you're drawing them. So it's really nice that they were able to share those files with us.
So don't think you can't go that extra mile and get what you want. Okay.
Right.
These days it's really with all the new technology and everything. Yes. Okay, so now we're going to talk a little bit about angles, specific types or measures. And oh, if you thought I had videos on other things, I've got too many videos. Apparently I just love the Braille Print Protractor because I helped bring it to APH. So there are tons of videos. If you think you don't know how to use it, just go to those videos and just if you can stand to watch me for too long. Okay, you need a drawing board again. I prefer using either the Intact Sketchpad or the Tactile Doodle or the Tactile Draftsman. There you can see some of our students using. I love the one with my student with his pinky up in the air. They're drawing his angles, and it's a lot of people look at this and don't know how to use it. So you may need to watch the video because most people say, tell them they have to turn it upside down to use it because they're anyway. I'm not going to tell you anymore. I'm going to make you go to those videos or make sure you get your Braille Print Protractor. Actually the instructions are authored by me, so you better I'll know if you've read them or not or gone to my videos. Okay, let's keep going. Number line graphs. Well, Sarah and I and Tina, who's not here today, we are just crazy about number lines. We just love them. So what we want the student to be able to do, of course, is to create them on a Braille writer because they can, and that's the way they're going to see them in their textbooks and on their assessments. First of all, I have so just want you to know that. We'll talk a little bit more about that in just a second. But also APH has a number line device, which you can also use to create number lines. So just keep that in mind. And then we have consumable number lines also from APH. You can even use some graph paper and just use parts of it to make those number lines. And then we even have, oh my gosh, so much information on Nemeth focused lessons number lines. And there's the link, and that's off to that Nemeth Braille Code curriculum that I was speaking of. And we have so many lessons and so many activities on number lines. If you're students and you love number lines too, we start from the beginning and just get more advanced. So you just go as far as your student or as far as you're able to go with them, and then you can stop and then continue later as your mathematics concepts increase. But what we have here is at the top, we have a number line that just has some points plotted. You can see it in print, and then we have the way you do it in Braille. And this is all totally copacetic with the Nemeth people, because I'm on the Nemeth committee and the Tactile Graphics committee at BANA. So this is the way we do it. We happen to be showing you the Nemeth number lines just to let you know. And then we have down at the bottom, we have graph of X is greater than or equal to -2. And on the right bottom, we have a graph of 2 is less than X is less than or equal to 1. And we're very quickly showing you these. You definitely need to go to the lessons or to some videos to be able to understand what this is all about. We just don't have time.
We have a
Oh,
question too. The number line device, yes, was recently discontinued this
Yes.
year. So we didn't write discontinued on there because we didn't have that at the time we were creating it. So they are asking if there's anything else available. There are those consumable number lines. And of course, the students do enjoy creating their own. So I also recommend that. And it looks like someone else had a Thingiverse 3D model of a number line too that they added.
So anyway, they do love. I know. Anyway,
they are recreating it.
They're
making a new one. Yep.
Okay. And let's see, am I okay? Is this? I'm trying to
Yep.
see if I'm. This
You're
is.
still, mhm,
Am I still continuing?
you're still
Okay.
continuing. Yep.
I want to make sure I'm not stepping on your toes here. Okay. All right. So we've got dot plots, also called line plots. So now we're getting into things that perhaps look a little more like actual graphics to you. And you can, as you can see, you can do this completely on the Braille writer because everything that you're seeing on the right side is all done in Braille. It can be done on a Braille writer. If you if you're so inclined, you could also do this type of thing on, if you're the teacher, you could do this on something like Duxbury or whatever. But this can all be done on the Braille writer, or you can use consumable number lines glued to Braille paper and put your stickers for X's. So this remember, we're having the students create these, so they have choices. They can do it however, whatever fun way they want to do it. Okay, so let's keep going. Pictographs or pictographs, my students he used to they just love doing these, and some of this is very, everything has to be just so, and the guide dots, they would just like, no, we want this to be perfect. Okay. And I was like, okay. And so we wanted to be perfect too, so we're taking this is a snipping of example 6-13 from the guidelines and standards for tactile graphics 2022, just to show that we are doing this perfectly as well. And again, something about pictographs that you do need to know is that the shapes must be a whole or a half unit. So you can't have, like, some pictographs maybe have a fourth of something, but if you're doing it in Braille, that is, you have to represent either a whole unit or a half unit. And so what we've got here, using the Braille writer on the left side, they have the little sand, the little time things, but we're calling that just a full cell. So what you notice is we've got a title, and then we have kind of a key that just says each full cell equals 4 years. And you'll notice this one is in Nemeth code, and it says each, and then it goes into a switch indicator telling you we're starting Nemeth, we're closing Nemeth. Then we have your box line, and everything else after that is all UEB down to the end. This would be in a textbook that's being done in Nemeth, but we only use Nemeth when it is necessary, in this particular case, and it's only necessary when we are writing that full cell equals 4 years. So let's keep it going and show you some more examples.
We have a question about where the guidelines and standards for tactile graphics are. Those are on the BANA website when you go to the code books.
Right. And just put in Braille Authority of North America, and it'll pop right up. Okay. Bar graphs, tactile graph paper and stickers you could use. APH hundreds board and manipulatives kit. We've got a picture of that. Math Builders Unit 8. We have data collection, graphing, and probability statistics. All kinds of manipulatives there. Or you can use the Braille writer. Again, I'm not sure that I would be doing this, but this is snipping out of example 6-12 from, again, the guidelines and standards for tactile graphics 2022. And by the way, when you do go to those guidelines, they are free. It's free. You can just, and it's basically, if you want to find anything, you can find things very easily on it. And I would really hope that you all are going to take advantage of that. We're still trying to get the supplement out. We've been pestering, and APH is they're the ones who need to produce it, and they keep promising us that it will be out soon. So I hope so, because we did it a long time ago. Okay, let's keep going though. And then we have circular pie graphs, and you can I've got a video on creating a circle graph on a Sewell board video, or creating it on a Draftsman. And we're just showing you some pictures of how to do that on the drawing board. We have a stencil or compass for the circle, protractor or straight edge to make sections. And then we have a tactile outline with marks for degrees. Student adds the wiki sticks, the graphic art tape, or graph binders to divide those sections. And we can have a pin or tactile dot for the center so that they know where that is. And then rubber mat and Braille paper here. That's what we have a picture of. And the spur wheel compass, which I'm not as crazy about, but I think it's been discontinued too, probably. But anyway, whatever you have, I just keep all my tools as long as I can. And then we have a tactile ruler or protractor to make sections. Okay, let's keep going. Now, Venn diagrams. Okay. I love Venn diagrams. The students are really pretty good at this. They love drawing the circles and making sure that the intersection spot is big enough for them to be able to braille in this case, 78. You will notice that I have got everything here in UEB. Truthfully, probably it would be done this way, whether it's in a Nemeth textbook or a UEB math science textbook, because all the numbers are whole numbers. So again, if you're a Nemeth person and you're saying, why isn't that in Nemeth? It probably will not be in Nemeth because of the fact that these are whole numbers. But you do, our guidelines do for the Nemeth says you may put them, if you would like to put them in Nemeth, you may do that. If your student wants to put them in Nemeth, of course they can do that as well. Okay. So just wanted to let you know about that. All right. And that is, you can, I'm sorry, I should have told you the drawing board, and then you need you need that compass, and then you need the braille writer to make that. I probably said it really, but okay. Coordinate graphs. Love the graphic aid for mathematics. It's kind of like the protractor. I've gone overboard. Lots and lots of graphing videos for you there. APH graph paper. You can use various choices there. Lots of different sizes and so forth. You can use besides the graphic aid for mathematics, you can make your own. You can have cork board and put some graph paper on top of that and use push pins and rubber bands. You can use Wiki sticks or graphic art tape for lines or axes, whatever you want to use. We take the graphic aid for mathematics, for example, and different people use yarn, they use rubber bands, push pins, all different kinds of push pins. I've seen electrical wire to make the parallelograms and so forth. Okay. Let's see. And I
So
think it's up to you now.
yes,
Okay.
yes. So box and whisker plots, and I'll show you on the next slide actual pictures of these. But I've listed 4 different ways that you can make these. You can do it with a Braille writer only, or you could use a pre-made tactile number line with tactile dots, and then graphic art tape or wiki sticks to create the actual lines or boxes. And you could use some combination of these. Let the kids be creative in how they're going to produce it. The key is that they have those horizontal values on a number line, that they have dots to represent the 5 key points, the maximum, minimum, and then of course the 3 quartiles, the median, and then the first and third quartile. And something thicker that's going to represent that boxed area. It wouldn't technically have to be boxes, but traditionally that is what it is. So I have 3 examples, or a couple of examples here. The first example is a consumable number line. I've even used just the graphic aid for mathematics, and those 5 dots can be the 5 push pins, and then your rubber bands can be created, can be put above and below those quartiles to make the boxes. So with the rubber bands. But with that consumable number line, I just used tactile dots, had the student use tactile dots to create where those 5 key points were and to draw in those tactile lines with the graphic art tape. On the Braille writer, they're just going to start with the number line, and then they can put the full cell where those 5 key points belong. And then they can use the letter X to connect those key points to make the box. And then they can use a dot to 5 to do the whisker part of the plot, which goes from the box out to that maximum or minimum. So there's lots of ways that they can create those box and whisker plots. So over the course of these 3 sessions, we have a chance to look at teaching students how to learn to read tactile graphics. And in this session, how to create their own graphics. So now that we've gone through that process of tactile graphics, we will be ready now to begin teaching students to create graphics virtually, digitally. We want them to move from making it hard copy once they have the basic concept to begin to use some of those electronic devices. For instance, they can create graphs using calculators like Desmos or the Orion TI-84 Plus talking graphing calculator. There is drawing software out there. I know I have done a short-term program using some of this drawing software. I had one that we used Tactile View and learned about coordinates and how to use those coordinates to make a graphic. Microsoft Office is accessible, so we can use Excel to put in a table and create a graphic from that. And of course, we can use the Desmos geometry software that recently came out, and we've linked to all of these. The one thing I will say about the Desmos geometry and some of these other drawing software options is that it is important that they have the basic concept down, and there can be some screen reading skills that are involved in them learning how to create these. And of course, now with the evolution of these full page Braille displays, like the Cadence, the Dot Pad, the Graffiti, and the Monarch, we can start creating some of these graphics using those as well. So I want to just say thank you very much for your attention today. I loved seeing all of the comments coming through the chat, and we'll make sure we get those up on the website. Do you have other questions for us that we haven't been able to answer?
I did want to say that we have, is it Aaron? We have someone from APH who, yes, Aaron, who says that some of the discontinued APH items may be a temporary situation for a variety of reasons, such as a product modification slash update. A vendor may have run out of material used to produce the product, etc. If you would like to know if the product is temporarily discontinued or permanently discontinued, please send me an email and I will look into it.
Thanks.
What if, is there a way that we can uh, ask that it come back even if it's been discontinued? Can we say that we, or promise that we will buy more, or maybe we all just have it and we just haven't bought it for a while because we all own one? Is there anything we can do there, Aaron?
Can you hear me?
Yes.
It might be a little noisy. I'm in the airport. Headed to APH for our math advocacy finals. Yes, the best thing you can do is to submit a request that the items be brought back. That would go to what we call our PIC committee, Product Innovation Committee, and they would review the reasons that you're asking for it. They would, if there is enough interest, they would ask more questions, look into it further, and possibly bring it back if it's a permanently deleted item. And then the best thing that you can do would be for somebody to create a request and share it with everybody that you know, and then have them send that in as well. The more that demand
More
that comes in,
requests you get?
yes. So literally that's how you put it in, share it with everybody, and just take a copy, paste it, and send it on its way. If if you want any further information, again, just email me and I can put these pieces of information back in an email to all of you.
Perfect. Thank you.
You're
It was
welcome.
mentioned too that the TI-84 was discontinued. That is still available through Orbit Research, as I think Maylene Bird put it in there. So those are still available, but not through quota funds any longer.
All right.
Okay, so we do have we have a few questions.
Oh,
Okay.
good.
How
Take on the
on earth, how on earth do you fit all of this teaching into the fast-paced general education math classroom? Our students take so much longer to learn to understand and then create all these things compared to the time it takes for their sighted peers to do so. What is the magic solution to the time problem?
I'll share a little bit about that. I mean, I know that time is always an issue, but the other thing I'll say is really the importance of starting early. Have the students create some of that even in those preschool years, so that then they get used to it and they get faster because they're doing more of it. So that's one thing that will help. And the other thing I'll say is just focus on what they need for what's coming up in the near future. Don't feel like you have to teach all of this at once. Look at what they're doing in the classroom and then do some pre-teaching of just those skills that are coming up in the near future. Susan, I don't know if you have anything else to say, but
No, I think you did very well. And someone just said, thank you for reminding me that we have great TVI math teachers. Oh, now, and Maylene, why don't you just speak up and instead of just, she's written something in the chat. So Maylene, why don't you, you say what you wrote in the chat? I don't want to put your words in my mouth.
I teach grade level math at TSBVI, and we have double block math classes every day at TSBVI, and it certainly helps. I will tell you though that we still struggle with that as well. And I hate to say it, but yeah, I have to cut some time out somewhere to cover everything. And so sometimes, you know, we don't do nearly as many of the in geometry. For example, we don't do nearly as many constructions as we should. But I try to cover everything somehow, some way, and double block helps. If you have a school with block schedule, they usually have a double block math class for students who are struggling in math, and that's the one I recommend for the VI students.
Thank you, Maylene.
So this is Leslie. I am the person who has to say we're at time. And I so appreciate Susan and Sarah's wonderful contributions and all the comments in the chat, and Erin with your wonderful, on the spot answers. So with that, I'm going to wrap this up, and this will be posted soon. And we do hope to continue these conversations in various ways. So first of all, let's see, before we head out, we have 3 important things to share with you. One, we developed a short post-evaluation survey of this series, and we really would appreciate it if you could take a few minutes to fill this out. Amanda's putting the survey link in the chat. There it is right now. We'll also email it to you, listed on the landing page, all the things. So this is not the only time you'll see it. We really value your feedback because we want to know how this material is best delivered for you. And I know Susan, Sarah, Amanda, and the whole team initiative really are constantly working to understand what works best for you. So don't be shy. Tell us what your dream is. We cannot make a 24-hour day a 36-hour day, but like the idea of a flipped classroom that someone just put in the chat. Well, maybe learning how that might work might be a tool that could work for a particular student or setting. 2, we have people ask about completion certificates for this series. Well, we are not able to track official attendance due to many watching after the fact, and we're not mind readers. We have developed a certificate of our participation based on the honor system. After you complete the post-evaluation survey, you'll have the option of filling out an additional form to request that certificate. Amanda will email one to whoever requests it within 30 days. Third, and most importantly, we have another webinar coming. Sarah Larkin, Tina Hertzberg, and Susan Osterhaus will be hosting another webinar next month on a deep dive into the digital math checklist that they created last year. And they're wonderful. Mark your calendars now for Tuesday, April 29th at 7 p.m. Eastern Standard Time. Amanda's putting the sign up link in the chat right now. And again, we'll email you all of this information and post it on our landing page, but share far and wide, listservs that LinkedIn, spread the word. We had over 400 people register for this webinar series that we just went through from around the country and around the world. We hear the need, and we're working really hard to meet your needs. And so this is a collaboration in many ways with you all out there in the audience, and so appreciate all your time and commitment to this series. So 3 cheers to our presenters tonight, to Amanda for logistics, and I just get to sit here and celebrate all this awesome work. Have a great night, everyone. Please suggest more topics.
Yes.
Absolutely. We'll keep this open for a few minutes to just let comments come in, suggestions, but be sure to toss those into the evaluation so we can capture them in a structured, formal way. So terrific. Look at all that. All right. So with that, I'm going to wrap it up. We will also have this transcript of the chat heading to you all as well. So have a wonderful night, and we will see you later. Good night.